Okay, this last projectile video is two problems in one to reveal a little bit about how speed changes and a couple other parts about projectiles. So a rocket is launched with a speed of 55 meters per second at 60 degrees above the horizontal. Calculate the speed of the rocket first when it reaches its maximum height, and then again once it has been in the air for 7 seconds. So here is the rocket. Goes up in the air and then travels some amount of that projectile. The initial velocity is down here. The maximum height is going to be there. And then 7 seconds, we can look at where that is at a later date. This picture is not going to be very informative to us because none of this question is about distance or displacement. So this question is all about speed. So I'm going to start by making my triangle. So 60 degrees is the angle, 55 meters per second is the speed at launch. Vy naught and Vx are the two components. So again, I said I was going to do trig faster and faster as we go. Vx is going to be 55 times the cosine of 60. 55 cosine 60 is 27.5 meters per second. Vy naught is going to be 55 sine 60. And so that's 47.6 meters per second. So now I set up a table, and then I want to consider what the question is asking me to find. So x and y. Delta x, I don't know. Delta y, I don't know. Vx, I just found. That is 27.5 meters per second. Initial vertical velocity, I also just found 47.6 meters per second. Time, I don't know. Vertical acceleration is negative 9.8 meters per second squared. I guess I bounced back to negative 9.8. Vy is complicated because there's two parts to this question, so A and B. In part A, the question says, what is the speed of the rocket when it reaches its maximum height? Maximum height is something that you might have touched on in the free fall part of this unit, and we're going to do it again. So maximum height, when an object is in projectile motion, if it's on its way up, it's slowing down, and then if it's on its way down, it's speeding up. The maximum height is the point at which that motion changes from upward to downward. So maximum height is when the velocity transitions from positive to negative, and at that moment in time, that vertical velocity is 0. Part B just says after 7 seconds, and so I don't know what that's going to be. And if I wanted to be thorough, I would do the same thing. For part A, I don't know the time, but for part B, it's 7 seconds. You don't have to do this, but I'm just trying to put everything in there. So part A and B, they end at different times, and so they have different values. So let's finish part A first. In order to know the speed when it reaches its maximum height, I have to know both components of the speed. The horizontal speed is 27.5 meters per second, and the vertical component of the speed is 0. So what do I do with that? Well, what these two vectors mean is that the motion of a projectile at its maximum height is only horizontal. And so all of the speed, all of the motion of this projectile at the maximum height is directed in the x direction. So the speed at maximum height is 27.5 meters per second. And so in the last half of the video, or last section, we're going to solve the other question, which is how fast it's going once it's been in the air for 7 seconds. Again, there's something important to realize here, and the time in the x direction of 7 seconds doesn't actually matter because the horizontal velocity is a constant 27.5 meters per second. However, the vertical velocity does matter. That time does matter. So I'm going to use this motion equation, and we're going to figure out what the vertical velocity is once it has been in the air for 7 seconds. So Vy equals 47.6 minus 9.8 meters per second squared times 7 seconds. Let's do that. 47.6 minus 9.8 times 7, and we get negative 21.0 meters per second. So this is a very significant result. This means that the object has begun its descent. So 7 seconds into its flight, it has passed its maximum height, and it is on the way back down. Now, we have something brand new that I haven't talked about in any video, calculate the speed of the rocket. So to find the speed, I need to combine these two vectors. It's going 27.5 meters per second in the horizontal direction, and it's going 21 meters per second in the downward direction. So I just took that negative sign and turned it into an arrow pointing in the negative direction along the vertical axis. So to find the speed at a certain moment for a projectile, you need to combine the horizontal and vertical velocities. I didn't need to do that in part A because there was no vertical velocity. So I have to now find this vector. So if I find the length of this vector, that is the speed. I could find the angle, and then I would be reporting the velocity, but this is just the speed, so I only need this value v. So this is the hypotenuse. So I'm going to use the Pythagorean theorem. That speed at 7 seconds is equal to the horizontal speed squared plus the vertical speed squared, square root of all that. So that's the Pythagorean theorem solved for the hypotenuse. So the final velocity is going to be 27.5 squared plus 21 squared, and then the square root of that. So the speed of this projectile at that moment, so 27.5 squared plus 21 squared, take the square root, is 34.6 meters per second. Okay, and just like an object going up and down a hill, on the way up the hill, the object slows down because of gravity, and on the way down the hill, it speeds up. So its speed at the top of its trajectory was 27.5, and once it reaches this 7-second mark, it's going faster than that. It has two components of motion that we had to put together to finish the problem, and that is that.